talk. We've got a two-part talk today. We've got Ashudeep talking about modernizing ColdFusion and deep dive into language enhancements. And we've got Vikas actually talking about some of the performance improvements that we have done to the engine that is coming up in the new update. Reminder, all of these sessions will be recorded. They will be on YouTube for a rewatch in case you have to head out halfway through or you want to tell your friends about it and have them rewatch it. If you have questions, and I'm sure there will be some, there's a Q&A pod right at the top there, right above the chat. Go ahead and please put your questions in there just so that we can get them at the end when we are going to do Q&A. And with no further ado, here is Ashu with a deep dive into language enhancements. Over to you, Ashu.
Yeah, thanks, Mark. And hello, good morning, everyone. Welcome to this session of Modernizing ColdFusion, a deep dive into language enhancements. I am Ashudeep, and I have been with this team for close to 9 years. I have been primarily working on language enhancements and even ORM stuff, DB stuff, CF query and whatnot. I also worked on GraphQL client. So yeah, let's start with the additions that we had. So the agenda for today is that we worked on enhancements related to Java interoperability. Then with this release, we are introducing sets data structures, and also AI is a particularly good theme in this release. And I'll just give a brief of how to leverage AI using CFML. There are some improvements that we did in exception handling, so I'll cover those. Then some of the query enhancements that we did, as well as some of the performance improvements which Vikas will talk about. Then there are some general enhancements, async related enhancement, and as always we added a couple of built-in functions which eases the developers work so that they can do quick things by writing very small piece of code. So let's talk about Java interoperability. So as with every release, right, we see that you know uh, developers uses a mix of CFML as well as Java stuff because Java has advanced set of libraries. So I'm going to cover about what was existing in the previous releases of ColdFusion and what we thought were lagging, and we tried to just patch it up and implement some new constructs so that that can be done very quickly. So the existing functionality was like create object that we exposed, and it was the most flexible object creation mechanism in CFML. It is being used to create Java, .NET, CFCs, COMS, and web services objects. We also introduced the dynamic proxy, using which one can implement a Java interface using a ColdFusion component, and using that you can do different stuff. We have CF Java tag, so in case some complex logic is there, you can just embed in the CF Java, and using that you can execute that class and just pass on the execution results to the CFML. But there were some concerns, and the concerns were really real in the sense that what we don't had was a Java function which is expecting a Java lambda expression. So for someone needs to know about Java full stuff and then what Java lambda expressions are, but we do have equivalent CFML lambda expressions as well, which we supported in ColdFusion 2021, right? So with this release, what we are doing is that we are providing a way in which a Java function or Java functional interface, which is expecting a Java lambda, and if we pass a CFML lambda, it should be able to interpret and execute that. Also, there were some lacking in the sense of the functional programming. We expose so many built-in functions for arrays, structs, lists, strings, and whatnot, right? And those and using those functions, we provide the functionality of like the functional interfaces like array map if you want to expose a map functionality, or if you want to convert something. But those had bit of caveats that those were expecting only UDFs so far. And what we thought of is that it was lacking a real complexity, in the sense that every time you have to create a new UDF, you have to pass it. With this release, what we are doing is, let's say fruits is a kind of array, and we want to do fruits.sum. Okay, so it was earlier expecting let's say only CFML UDF, right? So now with this release, what it can do is you can define a uh, Java predicate as well, and which you can pass, as well as any built-in function that exists in CF that you can use. More on it with some sample. So let's say we have this example, right? We are going to just give a brief overview of how dynamic proxy was working. So earlier, let's say if we want to filter something in this fruits list, right? So what we are going to do is we have to create a fruit list, we have to stream, and then we have to create a predicate. Predicate is again using a dynamic proxy. What we were doing is we are writing some function where we are creating a filters, and those functions are basically a new CFC, and using that we were initializing the instance of that CFC. We are going to define what that equivalent looks like in Java. So like this is equivalent to a predicate, and the logic is there. And then what we are going to do is that we have to pass that predicate, and it's going to give us the results of any fruit that is having a length of 6, right? So here banana and cherry. With this release, now this can be done just by writing a simple line of code, right? So you don't need to do all that complex stuff of creating a CFC, extending an interface, and knowing that whether it needs to pass a predicate or a collector or something like that, right? All you need to do is you just pass a CFML lambda here, okay, where it defines that I'm going to provide an input where the length of input equal to 6, and using that we are just going to get the same output which we were getting using this complex logic, right? So this is in a way simplifies the approaches. Uh, Another example that I'm going to talk about is that, let's say, the Java functional interfaces, right? So people use streams so much, right? So now ColdFusion runtime can automatically adapt CFML lambdas, closures, UDF into appropriate Java functional interfaces, be it predicate, function, consumer. So any Java functional interface which accepts, these SAMs at the call side, we can just pass a CFML lambda. So for example, we want to do a group by of these fruit functionality. So earlier, if we want to do it using Java, the way we have to do is using CF Java tag, or using Java construct. We have to write a kind of function which says that you just extract me, give me the first letter of that. Okay, so this is too much logic. Okay, now the new approach is you just do a simple CFML lambda, right? W and left W1, and it gives you the same output. So that's how we have oversimplified these things, where a developer has to write so much amount of code that can be done using a single statement. So, as per the enhancement, so what we did was that we have enhanced ColdFusion functional programming methods to support Java interfaces and ColdFusion built-in functions as the callback. Okay, and this enhancements also bring modern functional programming patterns to ColdFusion, making the code more concise, readable, and interoperable with Java, while also maintaining the full backward compatibility. We have introduced built-in functions as the callback. So all the built-in functions which were actually expecting a UDFs or a kind of callback route, right? So now they can be passed the ColdFusion built-in functions like is numeric, ucase, lan. All those are being accepted, as well as some of the traditional Java functional interfaces. Those can also be passed, and I'll show you. Each one has their own use case stuff. We are going to discuss it in the demos. So just take a sample example, right? So here is a simple CFML snippet which actually checks that from the items list, if we have to find out whether a value is numeric or not. What we had to do earlier before this release was we have to define a numeric UDF, which is going to again call the built-in function is numeric. Okay, and then we have to pass it in the array filter, for which the first argument is the array itself and the UDF, and it's going to give me the result of whatever the numeric values are, that is 1 2 3 and 4 5 6. If we have to do it using Java SAM, right? So the way to do it is we have to create a predicate class again using Java uh, function, okay, like Java code construct, and then we have to initialize that predicate class and then pass it, which will actually give us the same result. But think about it, right? Here it's like 2 lines of code, and we have created a mess out of it. But somewhere these things are also useful, and I'm going to explain in some of our demos as well. Okay, but here what actually makes more sense is just by using the built-in function, right? So what I did was the same list, the array filter function, I know is numeric is a built-in function called fusion. So why do we want to create a UDF and all? Why can't we just invoke the is numeric function, and it's going to give me the same result? That just by passing this thing, it's going to filter out all the elements of the array by applying is numeric built-in function, and it's going to give me the result of 1 2 3 and 4 5 6, these two values. Okay, Uh, so as per that, let's talk about the other thing, right? Where I said where these things makes more sense, where Java SAM, right? So I have two demos. I've created two demos. One is individual review analysis, and one is named entity recognition. So let me share that. So yeah. So okay, so this is my code for demo that I'm going to showcase. Okay, so my first demos looks like sentiment analysis that I'm going to do. Okay, and for that, what I'm going to do is I'm going to enter a text. Okay, with my name, and I'm going to just find out whether that is uh, you know that's a positive sentiment or a negative sentiment or a neutral, right? So if I give this text and I want to classify, right, it shows me that this is classified as positive. Okay, because it has so many positive words and zero negative words, so it gives me the confidence of 100%. Now let's think about how it did that, right? So let me go to the this function where we have, let's say, all the sentiments, or all the comments that are being described in an array. And then we have used the array map. We are going to pass the customer reviews as an array. Okay, and we have an analyzer, a predicate, right? So analyzer, it's a complex piece of logic. So basically, all that tokenization part. So what it did was that this snippet that I gave, it first converted into a tokens. So tokenizing in CFML, Java has advanced libraries as well, so we use that. And then we tokenize that, it converted it into tokens. And here, if you see the total tokens, it converted into is 25. And out of that, then we had certain positive and negative words as well. So some positive words are like, good, great, excellent. So this signifies positive sentiment. And then negative words, which are bad, terrible, horrible, and all. So using that, each tokens that we had, we identified a score, and based on that, we calculated a score, how much positive and negative. And this is being done in our apply function. Okay, so we have the positive words. So at every point of time, if my words contain, the token is a positive, is existing in a positive words list, then it's a positive score, else it's a negative score. And then based on that, I found out that if positive score is greater than negative, then classify it as positive, else negative, and all. So this is how we have done. Let me take another example. Okay, so there is this one another review, classifying the sentiment that I'm going to. So let me put this, and let me try to classify the sentiment, right? And it says that the review is classified as negative. Why? Because the negative words in this is like not, and there are multiple versions of not. One is this, and one is this, and then the terrible, right, which says it's a negative sentiment, and there is only one positive word, so the score of negative words are more than positive, right? So these kind of libraries which are there, which only exist in Java, right, we can use that. And that is where we can use our array map or different kind of built-in functions that we have, which were expecting only the ColdFusion user defined functions. Those can now expect a CF built-in function, as well as Java SAMs. Those are there. Let me take another example. Okay, so which is like entity recognition. So in this, what I did is, I'm going to give some statement, and based on that, it's going to recognize the entity, whether there is a person entity or a location and organization. And for that, like, I have some samples. So let's talk about this statement. Larry Ellison, right, is the executive chairman of Oracle Corporation and CTO. And this information, right, let me just put it, and let me extract entities, right? So it identified one person entity in the statement, which is Larry Ellison, two location, which is Santa Clara and California, and organization as Oracle Corporation. Now let's talk about how it did that, right? So the way it did that was, whatever statements or reviews that we are giving here, right, we can take it in an array. And then using array map, we try to pass that array with a processor, right? And here is what does the magic, right? If we go to the NER processor, so what it does is, it uses a Java library, which is open NLP tools, and it tokenize, and based on that, it tries to find out. Then it has its own model, like it has its person stream, like person model, location model, and organization model, using which it is fetching, it is giving tokens to that, and it is trying to categorize whether there is a person entity or a organization entity or a place entity, right? So all this logic those libraries right now are not there in CFML. So if someone wants to leverage that using Java, they can easily do, but the support should be there from the CFML side as well, right? So in the apply function, all that logic of whether that token is there. So first tokenizer dot tokenize it, extract the tokens and all, and after that, person finder is the person finder model. So it actually went into that and tried to classify, and then it puts the corresponding what was the text that we passed, how many person entities that we have, persons is an array, then how many locations that we found out. So that's how it is. We can take another example. So let's talk about Apple. Okay, so Apple recently announced that they are changing their CEO. So Tim Cook is stepping down, and we try to extract entities in the statement of Apple announced that Tim Cook will become executive chairman of Apple board of directors, and John Ternus, senior vice president of hardware engineering, will become Apple next. So it found out that there are two person entities. One is Tim Cook, one is John Ternus. There's no location in the statement, or at least it's not able to identify one. And then organization, it's able to identify Apple as one. Hardware engineering, maybe in the model itself they might be considering that this as a one of the organization. That's why it has found out an entities. So that's how you can even use now like Java predicates, and Java functional interfaces can be passed to the corresponding functions that we expose in CFML, and we can do the complex logic extraction. So as a part of this exercise, what we did, right? So the function supporting, so we had 9 operations in arrays, instruct also, struct teach, struct filter, up till like struct sort, list also 5 operations, query also around 7 operation. All these functions are now supporting built-in functions as well as Java functional interfaces. So you can just define a complex logic as a Java functional interface. You can pass to these functions, as well as if there is a handy CFML function or a built-in function that exists, you don't need to write closure. Closure logic was already supported there. You can just pass on the built-in function, and then that will do the corresponding execution. Next is sets data structure, right? So with every release of ColdFusion, we try to delight our customers as well as fellow developers to do something that is not existing in ColdFusion as a language, but those things can be done in a more like detailed manner, or uh, like less what do you call as less performant manner. So sets was one of the data structures we found out that it was lacking in ColdFusion. So with the current release, we are adding the support for set data structure. We already have the support for struct as well as lists and arrays. What is special in set, right? So a set is a fundamental abstract data type that stores a collection of unique elements. So like things, items in the sets are not repeated, right? Arrays or lists can contain like duplicate items as well, but here their primary focus is on existence and uniqueness. ColdFusion sets that we have supported support both ordering, right, and case handling. So ColdFusion sets can be ordered or unordered, or it can be case sensitive or case insensitive. It can store any type of value, objects, arrays, function primitives. Interoperability with and to from arrays and lists are supported. What set does not support is random access. So you cannot do, because those are not indexed, right, and you cannot directly update a value. uh, yeah, so let's go into details about, was this the only reason that we supported sets? No, sets has its own use case. So first thing is uniqueness of elements that we talked about. Then fast lookup, that at times one needs to store the keys, and uh, what they can do is maybe like put those keys in a struct by putting the key at the key value and value as null, but that is again unnecessary wastage of storage and all. And struct key uniqueness is not equal to item uniqueness. And then we have efficient set theory operations also that exist in linear algebra. So if someone wants to do a union, intersection, difference, superset, subset, and all that functionality is now being provided. So one can just put the data into the ColdFusion data structure and do these operations, because these are being provided at the first class functions as a built-in functions, right? Let me talk about the operations that we supported. So the basic operations of add, delete, remove, has, clear, is empty, copy, count, clone, and to array to list is being supported. Apart from that, the advanced operations like union, intersection, is subset, is superset, difference, symmetric difference, and all the map, filter, reduce, sum, every operations if you want to do functional programming and all. So all those are being supported. Let's do a comparative analysis of set, array, and struct, right? So the creation, just like for array and struct, we have corresponding new functions, array new and struct new. We have set new function. For clearing, we have the clear function. For getting the size, we have the count function. We kept in sync with struct. Array has len. And for delete, we have delete and remove. Then array has multiple versions of that. Contains also has, contains. Array has like contains no case. Then functional programming operations all are being supported, right? So that's a comparative analysis. So let's talk about how to use sets in ColdFusion, right? So the way you can define is you just provide set new and an array, okay, or a list, and it automatically creates a set of these products. Similarly, so we have wireless product, we have Bluetooth product, we have USB products, okay. And let's say if we want to find out the commonality between the wireless and Bluetooth products, right? Which products have both? So we just need to do set intersection of wireless product and Bluetooth products, and it's going to give me the result of what are wireless Bluetooth products. If you want to find wireless products that don't have a Bluetooth, so that for that you have set difference operation, right? You can just invoke this method, provide the corresponding sets, and it's going to give you. And then let's say if you want to find out products which are either wireless or USB, then you can do a set union. So just by doing this, you can see the output that we are getting. So the wireless and Bluetooth, which are both, are only headphone Z and mouse X, that is present in both. And wireless only that are there is laptop A and keyboard Y, that is there, okay. And if you want to find out the union, which are either wireless or USB, so we have around six products that are either wireless or USB. So using that, you can apply any different kind of operations that we have supported. Next is AI. So AI has been the hot topic, recently in last few years and all. So I'm just going to cover a brief about what we have provided. I think more of this has been already discussed in the corresponding sessions. So we have provided the API functions, like to get a chat model, which requires a chat model config. It has some required parameters of provider name and model name that you have to provide. We have an agent to create a to return an initialized AI service LLM agent based on the configuration. It requires a chat model based on whether you want to go with OpenAI or something else and all. Then vector store as well. So I'm going to discuss about the vector store that we have implemented. So to initialize that, you have to just invoke this API and provide the config. You have to provide the provider, whether it's Milbus or Pinecone or the corresponding like in memory and all, and the URL to that. Then we have provided a simple rack functionality as a built-in function. So using that, all the complexity that is there in rack, we are going to discuss about the functionality, but all the functionality that is there, that can be easily handled by has been handled by our product only. So you just need to provide the rack config, and you have to provide the query, and it's going to, and the documents you want to ingest, as using that it's going to answer. Then embedding model. So basically like if you want to create the embeddings and all, so for that we have embedding model API, and it has some mandatory parameters which are provider name and model name. Yeah, so let's talk about the database enhancements. So with this release of ColdFusion, we have supported vector databases. Okay, let's talk about a bit of history. So support for relational databases through query execute was there from the beginning. Then ColdFusion 2021 introduced the support for NoSQL databases, Mongo and Dynamo, which was further enhanced with the support for file store in 2023 release. Now ColdFusion with this release is currently adding the support for vector databases. Now what vector database is all about and why it is being needed, right? So a vector database is a specialized database designed to store and search vector embeddings, that is numerical representation of text, images, audio, video, code, that are generated by machine learning or LLM models. In the layman terms, what are the needs for vector databases? So let's say if we want to find out similar documents, article, or products which are similar in the intent, not textually. So for that, vector databases helps us. If you want to find out a similar images, like which images looks like the similar image, so for that there was no functionality, or at least that is being provided by the databases, the relational or non-relational or NoSQL databases. So all these things, so the images are being created as embeddings that are being stored, and then they can be retrieved, right? And let's say if you want to find out similar coding, right? So basically the the different kind of codes have been written in different kind of codes, but has the same functionality, that also can be done using the vector databases. And of course RAG, that we are going to talk about, right, retrieval relevant knowledge for an LLM, right? So that needs a vector database. So for that we have implemented. So I'm just going to give a brief about how those are being initialized. So if you see, right, vector store is the API. You have to provide the provider name. So this is the config looks like. The provider name is Milvus, then URL at which it is running, and the database name which you want to provide the dimension, then the index type. Okay, and then there are, the embedding model as well. So what are the provider? Is it Olama or OpenAI or something else? And then model name from the provider, and the base URL, right? So all these things. So this is what a detailed config looks like. But there are some mandatory parameters only, like 2 3 mandatory parameters which you can provide, and you can easily initialize the vector store. Okay, so let's talk about how it works, right? So here we have created a vector store. We have a document that we need to ingest. So for that document we have an ID which is randomly being created, then a text like I like watching sunset every day, and some metadata which we want to ingest. The way to do is, once you have initialized the vector store client, you need to do just add all for all the documents that you need to ingest. And then you can search results by invoking the search functionality on the vector store client, right? And here what you need to find out is the corresponding parameters that we have given is, I want to find out how much this query sun always set to rise again is similar to what we have ingested. Give me only top two results, right, with a minimum score of zero point 0.1. So there is a cosine similarity that happens. So again, that's a topic of vector store itself. And then we can just print the results. And on the UI how it looks like. So when you actually execute that, so it looks like, I like watching sunset every day. It has been created, the metadata is being there, then the score which is there, then the embedding which is again a vector or a matrix that looks like it's a probabilistic score based on certain dimensions and parameters. So that's how that also you can find out. Okay, so let's talk about RAG system for question answering. So with the advancement of AI and the corresponding models, which are coming every now and then, but there's a limitation as well, that models are trained up to a certain extent, as well as sometimes there's a personally identifiable information or some information which is not, which you don't want to become public. So for that, there's a functionality that if you still want to answer it using LLM, we have the RAG system. Okay, and how the RAG system works, again, it's a very brief diagram. So we have documents which are like PDFs, web, and data, and those are being splitted, and those are being ingested into the vector store like the one we showed. And after that, let's say if user is executing a query, right, that query is again using vector embedding model. A score is being created, and it identifies the relevant splits from the documents that it finds very close by. And after that, the prompt that we have written, using that, LLM uses and tries to answer that. Okay, now all this actually functionality is a bit of complicated stuff. So that if you have to write score, these things in Java or other languages, it requires an understanding of all the configuration. But we have simplified this thing. So using that, we have created a simple RAG, okay, function, which requires only few parameters. So one is test directory. That is the directory where you are trying to ingest the documents from, for which you want to query. Then the chat model which you are going to use, that is the provider. Okay, and what is the vector store that you are using, right? And chunk overlay. So that is basically minimalistic sort of information. Vector store can again be in memory, or it can be something like uh, Olama or something else, right? So that again depends. The only thing that you need to do is invoke the ingest function on rack service, and you can find out what are the ingestion stats. So we gives a very nice ingestion stats too. And then you can have some query like what is ColdFusion based on the documents that you have ingested. So you just need to use the rack service, and you have to just ask it, and it gives you the answers. The LLM answers that. It gives the response time, the tokens used, and all. So that is in a way has been simplified, just for if someone don't want to use the complex configuration and all. Next is exception handling. So exception handling, yeah, when we do write code, there is a possibility of exceptions being thrown and being handled, and also with every release we try to find out if there are some complexities or some things that we are missing. And this time there was some enhancement request from our customers as well as something that we identify. So we try to improve our exception handling. So what all we did in exception handling is, we allowed restricting exceptions to be thrown from ColdFusion code. So earlier, these exceptions like expression, log, database template, and all these exceptions a user cannot throw by their own, even if they know that it's a database related exception, because these are being reserved. We extended that, so we give that flexibility that you can categorize that. Then earlier, we were not throwing, catching the throwable, but only errors. And also now we are catching the throwables in Java invocable and wrapping them in a runtime exception for proper handling. As well as, we have changed the exception handler registration strategy. So what happens is, like, if you have registered certain kind of error handlers for a type of exception, earlier there was no way to have a one-to-one mapping. Okay, now what you can do is, even if you have registered multiple handlers for the same exception, the last handler wins, so that is going to get executed and not the earlier ones. If there are multiple distinct handlers that are coexisting, then different custom exceptions like exception type 1, type 2, for that we can have multiple error handlers. And then we have like case insensitive exception type matching as well, like, you can show something like my custom exception, and even if it throws my custom exception or those things, so all that thing has been handled. So this is like, type equal to expression was not allowed. After this release it will be allowed, and this is what the strategy looks like. So if you see here, we are trying to throw a exception which is of type E type 2, right? And we have here registered multiple error handlers. So though this can be registered in any order, but when we are specifying E type 2, that only the whatever the exception type that is defined in E type 2 page.cfm is going to get thrown, and that is logging exception. So it's going to get invoked and not the other ones. Next is query of query. So query of query, always surprises us with so many of our customers, checking on the operations, the new functionality, something that's not working now or now and then. So we had, some concerns around uh, the the evaluation of arithmetic operators, right? So earlier, how query of query was evaluating these arithmetic operators was, it was starting from the right? So like, if this is an example where, qty on hand has 96 value, and then qty 164 and then 32, what it used to happen is, it's going to just deduct 32 from 64, and then it's going to deduct 96 from this result, and it's going to give us the answer of 64. But if you talk about the traditional databases or the relational databases, the evaluation always happens from left, right? So we implemented the left associativity for arithmetic operators. The affected operators are plus, minus, multiply, and modulus, divide, and all what has been mentioned. So after this operation, if you see, now the evaluation will change. So first, the first two operations will be, so 96 minus 64 is 32, and after that minus the 32, so the result will be 0, right? So this behavior has been corrected. Then there were some external issues like, the is null condition was failing to return records containing null values. So what was happening was that if someone has a null value in a varchar or a text type, right? And if we provide this thing like name is null, it is not returning the records where name was null. So we fixed that now, after executing this, the corresponding record is going to get returned. As well as, QOQ was returning an empty row with zero value when using count on empty result set. Okay, so set count star, we identified the behavior what was there in relational databases, and it's always returns a single row with the corresponding like zero value. So just like this, it's going to give us this value of 18 which is there. Okay, and this query, if we talk about, it's going to give us a single result. So earlier this row was not present, so which was creating problems for some of the users. Again, there have been significant performance improvements which Vikas is going to cover after this session. Let me talk about general enhancements as well. So yeah, So literals, array literals, and struct literals. So this time what we did was we have implemented the ability to invoke member functions directly on literal values, like structure and array in CFML, without first assigning them to a variable. So now standalone literal invocations are possible. Even you can invoke member function on array literal, struct literal. You can use bracket and index access on the literal syntax itself. You don't need to create a variable and then use it. Literals is also allowed in expression and control flow. So anywhere where expression is expected, you can use the literal with the function invocation, and then we can have mixed array plus struct expressions. Just let me tell you this thing, right? So just like this is a array literal, and we can invoke a map function which actually multiplies each value to with 2, and then we can filter out using some, so it's going to return the result. So all this and corresponding chaining is being supported. And similarly, if you see, right, so this is modulus operator, and where it expects some of the operands, so you can provide those operands, so it's going to create the length or get the length on this array, and similarly the count, and you can execute. So any combination where expression is expected, now you can use by invoking member functions on literals. Let me showcase it with some example. So just like this is our corresponding struct that is there. Okay, so earlier this dot app, which is going to give us the result of this database. Dot app is actually this database full structure, and then finding the database, which is actually this snippet, was not working. After executing this, now you can get the deep nested access, which is host is local host, and port, and all that information is being there, right? So it can be accessed. Similarly, let's talk about member functions chaining in array literals. So this is an array literal. So earlier, what one needs to do is that it used to we have to initialize it to an array, a variable, and then we have to invoke the corresponding member functions. Now you can just do it in hand short place, right? So dot append. So using this, if we try to find out our second index we are trying to retrieve, that will have this array 23, 24, 25, and then we are going to append 43, 44, 45 with this. And then it becomes and then let's say we are appending a struct, okay, and then we are trying to fetch the element located at the fourth index, which is bum bang barley, right? So it's going to give, so any complexity it can handle now in the syntax. You don't need to create intermittent or temporary variables, which actually reduce the even the byte size as well as performance. Then we have UDF support in param statement and ternary Elvis operators. So earlier, what you has used to happen was that for ternary and Elvis operators as well as in param statements, the UDFs or lambdas or closures were not directly supported. You have to initialize it to variables and then provide. But now those are being supported right away, right? You don't need to create intermediate variables, right? So using that, all this piece of code which is having a lambda, right, in a ternary operator or like Elvis operator is being supported. Then there were some issues that were identified by our customers where nested array iteration was breaking the closure local scope. So that has been fixed. So that's an important fix that we made. So now all these things are not going to create issues. We have fixed it completely. Next, let's talk about asynchronous programming enhancement. So, asynchronous programming we introduced in ColdFusion 2018, right? And those are being used by our customers, but it was lacking some of the functionality which we tried to, improve with this release. So, let's talk about what was existing in run async. So, run async executes code asynchronously and return a future object, right? So, you just pass a callback or callback with a timeout or without anything. It's going to give you a future using which you can invoke the get method, and then you can chain as well, right? So that was existing. Now with this release, what we are providing is future aggregation as well. So let's say if we have a use case where we want to execute multiple future, and we want to do a future aggregation. Let's say all the futures should get executed, and then only I should do something. Or let's say by giving multiple futures, only one of them, whichever is the fastest one, if that gets executed, is fine for me. So that functionality we have added. In total, 30 plus new methods have been added, and those are fully backward compatible. Then some timeout handling method have been added. Chaining and composition are being supported. Then combining proper exception handling. So all this has been supported, right? Let's try to cover detail of the basic functionality. So like async all of, right? So in async all of, what it requires is it requires an array of futures. So basically, when is a web page that you want to load, right, and you don't want the request to fail until, or you don't want it to be getting displayed until unless everything has been completed. So what you can do is you can execute it using async all of function. You can provide the corresponding task to it, like future 1, future 2, and it what it will do is it will wait for all the futures to complete. And the only disadvantage is that it will return when the slowest task finishes, but in the sense that there's not going to be an incomplete information, and it has a single synchronization point, right? So it waits for all the futures to complete. Async any of is a bit different kind of use case, where let's say you have a use case of fetching a football score or cricket score from multiple websites, and you are okay with whichever site provides me the quick update. I need to return that. So in that, what you can do is you can create multiple futures, and after creating multiple futures, you can just use async any of, provide them the future list. Whichever finishes, it's going to give us the result, and it returns the fastest response, and other tasks are being ignored once this completes, right? Then some timeout methods. So sometimes a fellow developer is in a situation where they want future to like to return or to time out after certain time. So let's say if the job is taking more time, so what you can do is you can provide a timeout exception. So let's say the timeout you can provide in milliseconds, and it throws the timeout exception if it is slow, or else it's going to give you the result, right? So sometimes payments gateway, where you're trying to make a payment and all, so there is where this use case is being used. Then there is complete on timeout as well. So basically, what does is, like, when your future or the task is actually slow, there is an option to return a default value. So you can provide a default value with the timeout. So let's say if the future gets completed, it's going to return that value within, if it completes within the timeout milliseconds. If not, then it's going to return a default value. Sometimes there is a use case where the developer doesn't want to throw an exception or catch an exception. So for those kind of scenarios, you can use this. And then there is, like, if you want to combine, right? So if you want to execute a function after the both the futures have been completed, so what you can do is that you can execute those two futures in parallel, and then use the then combined functionality, and then the combined function, which will get executed only when the both futures have been executed, and it returns a new computed value. So let's talk about a bit of demos for this. So yeah, so like async demo. So async all of. So here, if you see, I have created multiple futures, future 1, future 2, future 3, which are creating a thread. And one is like profile data, activity data. So this is some kind of job that they are doing, and each one has a different method of sleep, right? So like one is having a sleep of 500 millisecond, one is 300 and 200. And when we call async all of, what it's going to do is, because async all of works, that it has to give the result only when all have been completed. So if you see here, when I call on this, it's going to execute it only after 500 milliseconds. So if you see, right, thread, the first task took 500 millisecond, then second is 300 and all. So my total job took 505. Indeed, if I, let's say, remove this to 200, okay, if I changed it to 200, and if I see now 305, because 300 was the this thing which is going to take the results, right? So that's how it is. Now let's talk about async any of. So in async any of also, I have created two jobs. One is, let's consider a caching kind of scenario where data is being read from a local cache, or from Redis, or from a database, right? And I have created multiple futures related to that with timeout each. So one is having 50 millisecond, one is 100, and the other is 500, right? So those things. So let's say, let me execute this using async any of, and all these three futures are going to get executed in parallel, and whichever finishes first is going to give me the results. So let me see what it looks like. So let's say there's a local cache, so it shows me 54 millisecond is the fastest future. So did we actually had the fastest? Yes, 54. Let me do this thing, let me create 10 to this, right? So then if we try to execute that, this will be completed within 10 millisecond itself, because data from the Redis was the fastest and all. right? Then like if you want to do complete on timeout or timeout, right? So that's the way that you can provide complete on timeout, whatever the timeout functionality and all, and it's going to say whether it has been completed on timeout or not based on the time that it is being taken. Or timeout also, you can execute that by giving a timeout and all, right? And then combine also, right? So all this is the functionality. So basically those are actually so yeah, coming to the built-in functions that we have introduced so far. So built-in functions, so we have added and enhanced some of the built-in functions. So let me talk about the added built-in functions. So we have added array get at, array find last, list find last, queries empty, struct get entries. Then these are the interesting ones, right? File mismatch. So file mismatch detects where the two files diverge. If you want to find out where the files are dissimilar, you can invoke this function. Then file read lines. So generally what usually happens in file handling operations is sometimes there is a utility or a use case where user doesn't want to load the full file in memory. What they want is, I want to, let's say, check the next 100 lines of the logs. Okay, so you just need to provide the file, the start line, and the count, the number of lines that you have to read, and using that it gives you just those many number of lines. Then we have also enhanced directory create function, which is going to expect a path parameter and the create path and ignore exists. So sometimes it happens is that you never know whether the directory is existing or not. So in that sense, what used to happen is every time it used to throw an exception if the directory exists, right? So for that, we have provided a flag using that. If we say ignore exist equal to true, it's not going to throw an exception, right? So let me cover a bit of demo in this. So yeah, so let me check this file. So I have two files here. So if you see here, we have two files, which is present in the, yeah, just give me a minute. Yeah, it's present in the built-in functions, right? Log file, yeah, test files, log backup and log current, right? And it's going to, the first line remains the same, only the second line is the difference. That is, one is having error, the other is having again info. And using that, what I have done is I have invoked this file mismatch functionality. Let me showcase the code. So what it did is, I am trying to get these both the files, getting the metadata of these files, and then file mismatch of file 1 and file 2. I am trying to find out, and using that I am publishing some of the stats, where the mismatch is, and it's going to give me, like this is the metadata. Then at which byte position 83, the file is different, right? So it's going to give me that information. Also, you can find out what was the difference and all very easily. And similarly, we do have a functionality of file read lines. So it's a pretty interesting one, I would say. So in file read lines, if you see, what I'm doing is I have a sample log.txt, which is this file, and I'm going to read it from, let's say, line number 125, right? And what I'm doing in this is starting at line 125, I'm going to just give me next 30 lines, right? So I've given the log file path, I've given the start line, which is 125, and the line count. So let me give a positive line count first and try to execute this. So when we execute, it gives me snapshot created and all. Let me check if that is the exact case, I'm getting the actual result, or it is something different. So yeah, snapshot created. So it is giving me this snapshot created. Now, an interesting thing is, let's say, what if I want to read 30 lines above it, right? So for that also, we have a parameter in which we just input a negative index. So if we execute this function again, if you see, it has given me the 30 lines above that line 125, right? So if we give into this thing, right, create database snapshot. So all these are the lines that has been outputted. So all that functionality you can do using file read lines. Now, yeah, so let's talk about function chaining, right? So yeah, so this is another demo. So we just checked these things, and yeah, this function chaining, right? So where if you see here, right, there are so many this is the struct little foo bar, and you can just execute. So all these functions that are available on struct can rightly be available. We are appending multiple key value pairs and then applying a UCase append, and we are trying to dump the map struct, and it has converted all the values to uppercase, right? And then because the value is being created as uppercase, right? And then for the similar for the array, what we have done is like one out of this, the second index is 23, 24, 25. We have appended 43, 44, 45, and then we try to fetch the fourth value which is there, okay, which is I think 43, and then we have appended something and the fourth value, and it's going to give us the result bum bang barley, right? So all that functionality is being there, that you can execute any complex form of literal the function invocations using index or using brackets and all. So all that is going to work with this release. Anything else that is being, yeah, let me show you one interesting, that is vector databases, right? So in vector databases, as we discussed about, so what I did was I had put in some of the queries that are there, right? So let's say these are the queries, or certain uh, lines that I have extracted. I have given a metadata. I am going to ingest it in a vector stores, which is Olama. I have run an Olama model, and after that, I have just indexed it using add and all the ingested documents will be there. And then what I've done is I have some queries to compare. So what I'm trying to do is, these are the queries that I'm trying to compare the score against whatever I have ingested, right? And I'm trying to get the scores, and I have put in something like, when we had the queries, I'm going to, once I have ingested in vector store client, I'm searching for those query text, okay, using, and the minimum score is zero point 0. And then I have categorized them into certain parts, that if the local score is greater than 0.63, then you provide it in a certain color like green or yellow or those kind of things, and let me execute that. Okay, so these are the queries that we have ingested. I have categorized into certain contexts, like something that is related to AI, something that is related to conference, something related to technology and all. And let's say when I try to execute, right, sun always set to rise again. So this was my query, that I'm trying to find out against these queries. So let's see how similar these queries are. Okay, so this query is having a similarity score of 0.71, because maybe sunset, this thing, so relevance is high and it is belonging to nature. Then if sunrise is there, that is also high. All other queries are not that relevant, that are having medium score of 0.51. So similarly, cold fusion conference, right? So that is having a maximum or matching score, more matching score with something cold fusion 2025 or cold fusion language, because here the words are there, right? But it is having a low score for something semantic search or sunset related queries and all. So this is how it looks like, and this is a score by score comparison, where you can find out that welcome to cold fusion language webinar, how similar this query is with ColdFusion conference in India. It is having a more similarity, but for other, like how do vector embeddings work or building web apps quickly, a bit of like it is having a relevance score of 0.71, but for all others it is having a low score, right? So you can find out. So all this query similarity, text similarity and all, you can easily do using vector databases. uh, yeah, so let me yeah, this already we saw. This is also, yeah, let's talk about set basics, right? So set functionality a bit. So if we talk about creating sets and all. So yeah, this is sets. So the basic functionality, how do you use set? You initialize set using set new. You have certain values identified. You just add it and you just dump that set. You print the size and all. You check whether the value is there or not. When we execute this, it gives me all the values that have been ingested. Size is three. Three values have been pushed in. This has element two. Yes. Then you clear the set and the size of set is zero. Now let's go to some advanced set operations. Okay, so in the advanced set operations, if I have to go, so this is the advanced set operations where we have given some values 1, 2, 3, 4, 3, 4, 5, 6 and all, and we are trying to find out union, we are converting it to an array, intersection, difference, symmetric difference, and all. Let's see how it works. So if you see, union of set A and B is 1 2 3 4 5 6, so it has combined, it has removed the duplicates that are there. The array form you can find out, so using that can be using union to dot to array, right? And you want to find out the intersection, only 3 4 values are common. Difference, which is there in first set but not in the second set, uh, right? So which is not there in the second set, that is 1 2, and symmetric difference and all the corresponding operations are there. Let's take another interesting one, which is performance like aspect. So if you see, what I'm trying to do is I'm just inputting some numbers into a random array and a set, and what I'm trying to do is, and then I'm trying to find out, right? And let's see the complexity, the performance that is it is happening. So the only difference is here we have inputted into a set data structure, okay, while here it's in array. And when we actually see the performance benchmarks, so it shows now 11.27x might not be the real this thing, but it is certainly more optimized as compared to array when we are doing a comparison. So that is the unique or power of sets that is there. And you can create different like friend suggestions, different kind of like if you want to create a social network kind of where you want to suggest friends, all that functionality, or e-commerce use case, that also you can do. So yeah, so yeah, that's all I have for now. Just that this I already showed, that you can use file mismatch, provide the files, it's going to give you the byte position where there will be a mismatch, you can print it. File read lines, you just specify the file start line, the line count, how many number of files. If it's a negative, it will print the lines upward, okay. And then directory create also, so you can just provide ignore exist equal to true, and it will make sure that it doesn't throw an exception. So yeah, that's all I have. Any questions, anything, feel free to ask.
I think while Vikas gets ready to do his part of the talk, I think the one thing was about the code demo files being made available, and I mentioned that they'll be put up onto the Adobe ColdFusion GitHub. So um, people are definitely looking forward to seeing some of the code and playing with it. So thank you so much, Ashu.
Yeah, thanks Mark, over to you Vikas.
Uh, Thanks, Ashu. That was very detailed and insightful session. Hi everyone, I'm Vikas Yadav, working as a senior computer scientist at Adobe. I have been with ColdFusion engineering team for around 7 years, where I have worked on various aspects, including compiler, code runtime, performance, VS Code, and many other. So today I'll be talking about the performance exercise that we had done recently, and some of the major improvement that we have done in ColdFusion. So first, we'll be looking at some of the competitive analysis that we have done, where we have compared ColdFusion 25 with other CFML engine. And next, we'll be talking about few of the improvements that goes into query and query and in other areas as well. And then lastly, we would uh, look at what all we have done even in the past recent release. So looking at the competitive analysis for the core engine, we have done a benchmarking against ColdFusion and other CFML engine, and the results we have found, I'll be sharing that. The first one is into the string operation, where we can see Adobe ColdFusion is leading almost in all the areas of the ColdFusion. That is string concatenation, length, trim, case, find, replace, and repeat, reverse, number format. So these are the basic string operations that is used most widely. And coming to the next, we have array instruct operation. So array little is basically the array creation, and then array append, array find, array sort, struct literal, and there are different. There are others as well. For the sake of simplicity, I've just kept few of them. And here also we can clearly see Adobe ColdFusion is leading almost in all the front for array instruct. Okay. Then coming to regex operation. Uh, in regex as well, for array find no case. So most of the regex operation as well, ColdFusion is leading. And then there was this benchmarking was done against the major control flow that we use, and Java interoperability. For major control flow, we have used if else, switch, for, while, and break, continue. So these are very uh, common, or very common to the language, and these are most widely used construct in the core engine. And we've also checked on the instantiation for Java interoperability. We have checked on the instantiation of hash map and string builder. So any object that we can instantiate using the Java create object capability of ColdFusion. So as we have seen, well, benchmarking against the other CFML engine, ColdFusion, Adobe ColdFusion is leading almost in all the fronts, and that translate to uh, compute saving as well when we are talking about the performance at a large level. Coming next to query of query performance. So there are certain improvements that were done in 25 with respect to 23. After that, also we have done a lot of improvement in query of query. So these are a few of the improvement that I've listed. The parallelization, we have parallelized the critical section of QOQ, and there was some improvement with algorithms. We have now used a more efficient algorithm for querying, and there was some optimization with respect to memory as well. So that will reduce the garbage collection pressure, and would it would increase the response time as well. Yeah. So as you can see here, QOQ performance. So we have got a gain of around 11x performance, and with CF25, this benchmarking is done for various for various aspects. So one of them is large data set, uh, memory and resource monitoring, and then aggregate operation, grouped aggregate, like operator, and select operations. So these are the average of all the operation we have got, and the number says we have around 11x improvement with respect to the previous version. So in the last data set, we can see we have got uh, around 18x improvement, and for aggregate and all, we can see we have around 390% improvement. For grouped aggregate, 171%. So overall, it is 11x improvement. So when we want to see the detailed result, where exactly we have got how much, for basic select, we have around 136% improvement. For computed field, we have around similar. For union, join, like operators, and the most improvement we are seeing about the larger data set when we have more than 1.5 million rows. So we want to see that the same data over the simple representation. You can see the blue one is ColdFusion 2025, the latest one is, and the red one is the previous version, so CF25. And we can see there is a massive improvement that were done in ColdFusion, that are done in QOQ. So when we have done the benchmarking of the improvement, so the previous, all these were against the previous version of ColdFusion. Now we have benchmarked it against the other CFML engine as well, and we can see the ColdFusion numbers, Adobe ColdFusion numbers are better than the leading CFML engine. So we see the leading CFML engine is around 10% slower with respect to QQ. So we have the numbers here for join operation like large data set, computed field, and multi-table union. So this is one of the example that I've shared here. So the query is select these along. I think this is a group aggregate query we have. We have where clause where we have age greater than something and is active. Then we have a group by, we have a having and order by. So this is some of the complex query that we had, and we tried to benchmark it against. So if we see CF 2025, the results were not that good, and the blue is Adobe ColdFusion, and the orange one is the other CFML engine. So initially we were not that good, and after the performance exercise done for QOQ, we can see the Adobe ColdFusion is better than the leading CFML engine as well. Okay, so apart from that, we have also done some of the improvement in string sort and string handling, string concatenation, and there were some improvements that were done in the previous version. They were mostly in CFSTTP. We had got around 120% improvement with CF component. We had around 6 to 10% of improvement with structs. We have got around 6% of improvement. And spreadsheet we have around for spreadsheet read we have got around 165% of improvement because we have introduced streaming in the last release. So there's those were certain other improvements that were done recently. So overall, to summarize, so there was a massive improvement on QQ, and the improvements already we have talked about, and overall the Adobe ColdFusion leads on the raw throughput, and we do these kind of benchmarking exercise against CFML engine time to continuously improve Adobe core engine. So overall that was all I had. Any questions?
Very awesome. I don't see any questions. Does anyone have any questions for Vikas or even for Ashu? Any questions from the previous demo from anyone? No. Awesome. Well, thank you so much, Vikas and Ashu. That was awesome. This is being recorded, will be posted, as mentioned, to the Adobe ColdFusion YouTube, which is linked down below. And a lot of the demo code will be pushed up to the GitHub. If you're interested in trying out the beta, it's available now. So a lot of the stuff that's in these talks is in the update beta. We just had a brand new drop. It's the last drop before we go live. So run over there, check it out, sign up, download it, try it out. It's pretty awesome. And hopefully I will also see all of you at CF Summit coming up in June. So if you haven't signed up for that, please do. Awesome. Well, thank you, Ashu and Vikas, for coming out and doing this talk for us. And that is actually it for our webinar series. I want to thank all the folks that I've seen come to every single one of these. You know who you are. I have seen you come every day and really appreciate all the support that you're showing our team. Really, really excited to hopefully see you all at Summit. And if you have any other questions, please feel free to email us or Slack us or post on the forums. We're everywhere. So our Inboxes are always open, and we are happy and excited to hear from you. So that is for now. That's it for now. I'm going to go ahead and stop the recording.